Linear inequalities in two variables. A linear inequality in two variables x and y is an inequality that can be written in the form ax plus by is less than c, or ax plus by is greater than c, or the same thing with the little equal to bar under it, where a, b, and c are constants and a and b are not both 0. Now I want you to remember the standard form for the equation of a line is ax plus by equals c. So I just want you to always relate it back to this. What you have here is just an inequality of a line that's already in standard form. Solve the following linear inequalities by graphing their solution sets. Well, whenever you solve an equation, you just get an ordered pair as your solution. Whenever you solve an inequality, you get a whole region of ordered pairs as your solution. What I think you should do first is go ahead and solve this for y. So we're going to subtract 3x from both sides. We'll have 4y is less than negative 3x minus 12. Now what we want to do is get rid of the 4, so we're going to divide everything by 4. Y is less than negative 3/4 x minus 3. So now we have it in slope-intercept form. Go ahead and graph this as though it were the equation y equals all of this stuff. So we would graph our y-intercept, which is negative 3, where we can either rise negative 3, then run 4, 1, 2, 3, 1, 2, 3, 4, or we can rise positive 3 and run negative 4, 1, 2, 3, 1, 2, 3, 4. And what we want to do is connect those points and draw a line. But you have to be really careful with this, because the kind of line you draw can either be dashed or it can be solid. If you have a dashed line, it means you do not include any of the points along that line in the solution set for this equation. If it is solid, then you do consider those points on that line as part of the solution set. Well, here's the difference. If you have less than or greater than, you're going to have a dashed line. If you have less than or equal to, or if you have greater than or equal to, you're going to have a solid line. Because that just means you include it. This one means you do not. So you would connect these points using a dashed line. There you go. Now this says y is less than this line. Well, which way would be less than? Would it be on top of the line, or would it be below the line? Less than would be below the line, right? In that case, you want to shade the region that is below that line. So all of this area right here, everything in this area is considered your solution set. I know it's not very pretty, but that's how it's supposed to be, I guess. Now to check your answer, you could actually test a point. Test a point or two. Pick a point out here in the solution set. We could pick, let's see, this is negative 4, negative 5, negative 6. Let's pick negative 7, 0. We think that this is in the solution set of this inequality. We'll put negative 7 in for x, put 0 in for y. 3 times negative 7 plus 4 times 0 is less than negative 12. 3 times negative 7 is negative 21. 4 times 0 is 0. Is negative 21 less than negative 12? Yes, it is. So that point at least tells us that we did this problem correctly, or we shaded the correct region. Okay, so how about this one? Go ahead and solve it for y. So you'll move the x over. You'll have y is less than or equal to negative x. Y equals negative x, which if you remember is a line that goes diagonally. The slope is negative, so the line is going to be falling from left to right. So to graph this line, we would plot the points 0, 0, negative 1, 1, negative 2, 2, negative 3, 3, like that. So this would be our line, and we know that it's solid because this has the little equal to symbol under it. Remember, if it did not have that little equal to symbol, then we would make a dashed line. So the next thing that we need to do is figure out where to shade. Well, this one says y is less than or equal to this. Less than would be below the line. Remember, this is above the line and this is below the line. So you would shade everything on this side of the line. This would be the solution set. Okay, so how about this one? Y is greater than 5 halves. Well, look at the line y equals 5 halves. Where is that? So y equals 2.5 would be somewhere in here, which means we need to draw a horizontal line at y equals 5 halves. Now, do we draw a dashed line or a solid line? This does not have the little equal to symbol under it, which means we do draw a dashed line. So here is your horizontal line at y equals 5 halves, and it is dashed. It's really difficult to get that right on the 2.5 mark, so just pretend. So this says y is greater than 5 halves. That means we need to shade on the top side of the line. So in this case, it would be here. This would be your solution set, everything above that line.